Just brotherly. Today we're going to do a very stupid things. It's not related to anything to 3D art. It's just really just for fun. So let's firstly go to scripting. Where's my scripting? Scripting. Huh? I don't even know where's the scripting. So the text editor. So let's add a new file. So basically there is a famous Monty Hall problem. So basically it means you have 3 doors. And one of one contains treasure or car or whatever that stuff. And you open one of the door. And then the people who know everything will open a door with nothing. Open a door with nothing. Okay. Will open a door with nothing. And then the question is, will you switch the door? So there are 2 kinds of proposal. One proposal is it's a 50-50 because you only have 2 doors left. The other proposal is that you have 2/3 chance if you switch. And I know probably people already proved this, but I think it would be interesting if we can do this by our own using animation nodes, because we need a loop. So basically there's I forgot the name of the theory. It means when you, so it's like drawing a lottery. If you repeat an action as many times as possible, then the results will be closer and closer to the statistical truth, sort of kind of speaking. So basically we're running a loop of this kind of action, and then we will try to calculate the probability whether we should switch or not. Okay, so this is kind of idea. So how to do this with animations? Again, this is not related to 3D art, but I just for fun. So we need a loop. So of course we need a loop input, but the question is whether we put it within the loop input. I'm going to create an integer list, and then I'm going to 0, 0, 1, 0. It does not really matter with the order because we're going to draw a lottery between them. So let's take a get random list element, and we're trying to draw a single element from this list, and then we output the element whether it's 0 or 1. So 1 is the treasure, 0 means nothing. Then we are going to remove this element, remove this element. So we take this based on the index. So based on the index, put the list into. So now we draw a lottery. Actually, let's just take a look with the lottery that we draw. So now we only have 0 and 1 left after this drawing the lottery. Actually, I'm going to put probably up. So this is the result. I think currently we obviously do the 1, since the 1 is in the rest of population. This time we did not actually win the lottery. But anyway, it does not really matter. So we have these 2 elements. I'm going to eliminate the one that has not the lottery. So here we try to remove list element again, and use the, I think this, but this time we are going to use the first occurrence and remove 0. Okay, so this is the remaining list. So here we're taking a switch because we want to know whether you would like to switch or not. So you can use the true and you can use the false. Here it will give a get list length. This is a false. It's because this is a list even if it actually contains only 1 value. So we need to make it a single element, so we use the get list element. My mouse is not working recently. Okay, so once we have this, I think this is good enough. the other things that we need to do is to actually change the seed. So that's why we need a loop. So every time we use a different seed. So here there is a preset which is called index seed. You can get it from the preset library. Basically what it does, actually I do not want to use preset in this case, just to keep that as vanilla as possible. So we add a mass and then we multiply. So take the index, add 1 and then multiply. Put that into parameter and then we put that into the seed. So then we are going to output the result, the integer list. So here's, we're going to use this, we're going to put the switch back to the parameter. Okay, so then we're going to create the invoke node, just hit W and it goes to right. Okay. So once we have this, as long as you run all this kind of iteration, then you will get all this kind of result, whether you actually get the amount or not. Actually, I'm going to change this into the integer. And take these. Yes. And remove this seed. Name as a seed. Okay. Okay, so now we have all this. Do we actually have this bad luck that's it's completely 0 all the time? That's so bad. Okay, then we're going to determine how many 1 that we have within this list, because you obviously not going to count by yourself. So we're going to run a function. So there is a node which is called a mask list. All this kind of boolean, the yellow output, is basically 0 and 1. So this also applies to geometry node. You put a integer list into the list, then you put the integer list into the mask, which means it will output everything with 1. Okay. So now we isolate all this kind of 1. So now we are going to divide this amount of 1 to the original total amount. So we take the float mass and we are going to take a get list length twice. So one node, the other node. So we want to know how many 1 that we have, and we want to know original amount. Actually, the original amount must be equal to the iteration. So this is for sure. So you can see the increasing iteration, then we increase the output amount as well. So here we just take the numbers and we take the divide. Okay. So once we have done this, we're going to see the result. So it says if the condition is 1. So what's the condition 1? Condition 1 means we are using the initial get random list element. So we do not switch. So here let's just type that do not switch. Not switch. So if we do not switch, we get 33, basically 33%. But if we switch, we get 66%, which means 2/3. So we basically proved the problem, and definitely you can definitely increase the amount to 1,000. It still gives the same result. Actually, even just by 5. So in lower the iteration, more inaccurate the number is. But if you increase the iteration, then it will be closer and closer to the actual result. Okay, so you just type the 1,000. And you can change the seed. It still keep the same result. It does not really change. So switch the door, you will have a higher chance to win the lottery, kind of stuff. Yeah, this is really we're not producing anything shady, but I just think this is fun. Just a note, I think in computer, the random number is not actually the true random number. But I don't think it doesn't really matter in this case. because it's I think it's fair because it's the same. This is equally true to all the system in this case. This is really fun because so now you really proved, oh, you need to switch the door. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.